Building software isn't just about writing a bunch of code. It's actually a lot like being a detective. You're constantly on the hunt for clues, you're investigating strange incidents, and ultimately, you're trying to solve the mystery of what went wrong. So for the next few minutes, let's put on our detective hats and get to work. We've all been there, right? You're in the middle of doing something important, and then, poof, the app just freezes up, it crashes, or it does something totally bizarre. It's so frustrating. But that crash, well, that's our mystery. It's the final scene of a crime that actually started long before you ever even launched the app. So, where do we even begin our investigation? We start right at the scene of the crime. See, every software failure, just like any crime, leaves behind a trail of evidence. Our job is to follow that trail, to trace it back from the crash you see on your screen all the way through the code to find the real culprit. Now, to solve this mystery, we first have to understand the basics of software failure. It's not just random chaos. There's a really clear chain of events that leads from a tiny human mistake all the way to that app crashing on your phone. Okay, this is super important. It all starts with an error. That's just a human mistake, maybe a typo or a simple logic flaw made by a programmer having an off day. Now, that error creates a fault, which you might also hear called a defect. Think of it like a hidden flaw, just sitting there in the code, waiting. And the failure? That's the part you see. That's the moment when that fault gets triggered and the system just doesn't do what you expect it to. So remember the chain. An error leads to a fault, which can cause a failure. So who are the usual suspects here? Well, the culprits are often very human. It could be something like a communication gap, where the developer just didn't quite get what the client wanted, or maybe unrealistic time constraints, forcing everyone to rush. And of course, there are simple programmer mistakes, not having a big enough budget, or just not fully understanding the requirements from day one. With so many things that can go wrong, how on earth do we build software that actually works? Well, this is where the heroes of our story come in, the processes and disciplines that are all about preventing and finding these failures before they get to you. So people mix up the terms testing and quality assurance all the time, but they are totally different things. Think of it like this. Software testing is like the detective showing up at the crime scene. Its main job is to find bugs in the final product. Quality assurance, or QA, is more like the crime prevention unit. It focuses on the entire process, trying to prevent bugs from ever happening in the first place by making sure the software is built the right way. So one finds flaws and the other tries to stop them from ever existing. And here's the thing about quality. It's not a one-and-done deal. It's a never-ending loop, what's known as the PDCA cycle. You plan your goals for quality, you do the work and build the product, you check your results to see if you met your goals, and then you act to make the process even better next time. Then you do it all over again, always improving. Okay, so we get why we're investigating and the mindset we need for quality. Now let's open up the detective's toolkit and look at the actual techniques that are used to hunt for those hidden faults in the code. It's the million-dollar question, isn't it? How do you actually find these things? You can't just click around randomly and hope you stumble upon a problem. The hunt for bugs needs a real strategy and a very specific set of tools. And here are the two main tools in that kit. First, you've got black box testing. This is like an interrogation. The tester knows nothing about what's going on inside the code. They just focus on the inputs and outputs, asking, from a user's point of view, does this thing do what it's supposed to do? Then you have white box testing. This is the forensic analysis. Here, the tester has full access to the code. They're digging into the internal logic and pathways to answer a different question. Is this thing built correctly on the inside? So during that black box interrogation, testers are using very structured techniques. They're not just guessing. They might use something called boundary value analysis to check what happens at the extreme edges of an input field, or use case testing to walk through a typical user's journey step by step. It's all very systematic. And for the forensic white box analysis, the techniques get even more detailed. Testers will use things like statement coverage to make sure every single line of code actually gets run, or path coverage to test every possible route a piece of data could take through a function. This is all about making sure the internal machinery is rock solid. A good detective never just wings it. A real investigation requires a master plan that maps out every step, every resource, and every goal. And in the world of software, it's exactly the same. That master plan is called the test plan. It's a detailed document that acts as the blueprint for the entire testing operation. It spells out exactly what's going to be tested, how it's going to be tested, who's going to do it, and by when. Honestly, without a test plan, testing would just be chaos. And a good test plan is incredibly detailed. It lays out the whole strategy, the scope, meaning what's in and what's out, the resources you need, and the schedule. And maybe most importantly, it defines the entry and exit criteria. These are the strict rules that say, okay, we're ready to start testing, and all right, we've done enough, we can stop.
So far, we've been talking a lot about finding bugs, things that are clearly broken. But a truly great app has to do more than just work. It has to work well.
And that brings us to another huge distinction: functional versus non-functional testing. Functional testing answers the question, does the feature work? Like, if you click the save button, does it actually save your data? Simple. But non-functional testing asks a totally different question. How well does the feature work? This is where we get into things like performance, security, and just how easy it is to use. And the scope of this non-functional investigation is just massive. Testers are checking for performance. Is it fast enough? They're checking security. Can it be hacked? They're looking at scalability. What happens if 1 million people suddenly use it? Compatibility. Does it work on your old phone and your brand new laptop? And recovery. If it does crash, can it get back up without losing everything? So, after all this technical stuff, all the plans and tools and cycles, what are we really trying to do here? What does quality even mean in the end?
I think the quality pioneer Joseph Juran said it best. The ultimate test of quality isn't about having 0 bugs or a perfect process. It's about whether the software is fit for its purpose. Does it solve the user's problem? Does it do it in a way that feels good? That's the real goal. And our whole way of thinking about this has evolved so much over time. We started with just simple inspection, basically checking the final product for mistakes. Then we moved to quality control, where we started hunting for the root cause of those mistakes. That led to quality assurance, which is all about proactively fixing the process to prevent mistakes. And today, the best organizations aim for total quality management, where creating quality is part of the culture for everyone. When you really stop and think about it, software is the foundation of our entire modern world, from our banks to our hospitals to how we talk to our friends. And every single time you use an app that just works seamlessly, that's not an accident. It's the result of a deep, deliberate, and tough investigation. So the question we're left with is this: as we build more and more of our lives on top of this foundation, how do we make sure it's strong enough to hold us up?